Ever since their early days, SpaceX and Blue Origin have been locked in an intense private space race. Still, in recent years, the gap between them has only grown wider. Elon Musk's company keeps charging ahead with massive projects, while Jeff Bezos' venture struggles with delay after delay, slipping further behind. Things have gotten so bad that even a much smaller player has now managed to embarrass them, and that is Rocket Lab. So, what exactly did this little space firm just pull off that's making the giants take notice? Let's find out in today's episode of Alpha Tech, Blue Origin and Rocket Lab. When you hear these two names, most people would assume Blue Origin must be the bigger, older, and more successful company. And on paper, that's true. Founded back in 2000, 2 years before SpaceX, by billionaire Jeff Bezos, Blue Origin now has around 10,000 employees. The company has built up a massive workforce to support huge projects like New Glenn, New Shepard, and Blue Moon, even winning multi-billion-dollar contracts from NASA. Rocket Lab, meanwhile, is a much smaller outfit, with only about 1,500 employees, limited revenue, no billionaire backing, and constant financial pressure. But here's the paradox. It's actually Blue Origin that's falling behind. The company has been plagued by repeated delays with its New Glenn rocket and persistent technical challenges. Their NG-2 mission was originally planned for August 24th, but the date has already slipped 3 times, with no sign of a launch anytime soon. Even more telling, it took them 13 years just to get New Glenn off the ground for the very first time earlier this year, far from the company's original promise to launch back in 2021. Rocket Lab, on the other hand, may not be seen as a direct rival to the giants, but the company has made some truly impressive strides. In just 7 years, it has launched its small Electron rocket more than 60 times, already a more consistent track record than Blue Origin's New Glenn. And now, Rocket Lab is preparing to move up a weight class with its upcoming medium-lift rocket, Neutron, which is expected to fly for the first time later this year, after only 4 to 5 years of development. That debut flight will mark Rocket Lab's entry into the highly competitive market of major commercial launch providers, where the battle is fiercer than ever. And in preparation for that milestone, Rocket Lab has recently made a bold move that's turning heads across the industry. Just over a week ago, Rocket Lab proudly broke ground on the construction of its brand new launch complex, LC-3, where the Neutron rocket will one day lift off. And the timeline is ambitious. Completion could come as early as the end of this year. Located at the Mid-Atlantic Regional Spaceport at Virginia's Wallops Island, LC-3 will support Neutron's testing, launches, and recoveries, making it the largest vehicle ever to fly from that site. Of course, largest is relative here. If Neutron were to launch from Kennedy Space Center or Boca Chica in Texas, it would look almost tiny since it's still noticeably smaller than SpaceX's Falcon 9. As we prepare for our next generation rocket, having a world-class launch and landing site is exactly what we need, said Rocket Lab's CEO Peter Beck at the ceremony, which was attended by Virginia Governor Glenn Youngkin and other state officials. Neutron's high launch cadence will expand domestic capability and enable the United States to rapidly and reliably reach the ISS, Earth orbit, the Moon, and beyond. Rocket Lab sees Neutron as a strong contender to ease the growing bottleneck in launch demand from both commercial and military customers. Right now, that demand is largely being met by just one player in the medium lift market, Elon Musk's SpaceX. The ultimate goal for Neutron is to support some of the most critical and complex national security missions for the Department of Defense. At the moment, only SpaceX and United Launch Alliance are certified for these missions, though Jeff Bezos' Blue Origin is expected to join once New Glenn clears all certification hurdles. But let's be real, that day still looks far off. Blue Origin recently scrubbed its second New Glenn launch due to a booster avionics issue, adding to an already long list of setbacks. Until New Glenn is finally ready, Rocket Lab has a real shot at outpacing Blue Origin in satellite launches, possibly dominating their share of the market for the next 2 or 3 years. In fact, just last March, the U.S. Space Force added Rocket Lab to its $5.6 billion National Security Space Launch Program, giving Neutron preferential treatment for a range of lower-tier military missions. For Rocket Lab, this was one of the biggest wins in its history, proof that the small company is finally being taken seriously in the big leagues. But that recognition also raised the stakes. Before breaking ground on the new launch complex, Rocket Lab had to think carefully about whether Neutron could really live up to its potential. After all, leasing and building a launch site is no small investment. If their new rocket doesn't perform as designed, the whole effort would be seen as a major failure. And let's not forget, Neutron hasn't even flown a single test mission yet. Of course, maiden flights always carry risks, from accidents to disappointing results. That's why, just a few months ago, Rocket Lab carried out extensive testing to ensure safety. On X, they posted, "Pointy end up." Testing is underway and close to completing qualification. This Neutron assembly represents the top of Stage 1 and includes the Hungry Hippo reusable fairing, canards, and the extended interstage with some of the most complex mechanical systems that exist on the vehicle. The accompanying video is just a 3D simulation, but it clearly illustrates how this rocket is supposed to work, true to its nickname, the Hungry Hippo. Unlike traditional rockets that jettison their payload fairings into space, Neutron's fairing is built from carbon fiber composite and permanently integrated with the first stage booster. Instead of being discarded, the nose cone splits open like a giant mouth to release satellites or spacecraft into orbit, and then closes back up for the booster's return to Earth. Rocket Lab calls this the Hungry Hippo design because, well, it really does look like a hippo opening its mouth wide. Pretty clever, right? On top of that, Neutron has also gone through simulated flight operations under cryogenic conditions, along with integrated software, avionics, and guidance system testing to recreate real mission scenarios. Even more impressively, the stage has passed pressure and load tests at 125% of its maximum operating pressure while under mechanical stress, proving it's ready for the journey to orbit. Rocket Lab has also highlighted one of Neutron's most unique design choices, the second stage, something fans are especially excited about. Unlike traditional rockets, where the upper stage sits on top of the booster and is supported from below, Neutron's second stage is actually suspended from above, hanging inside the first stage's fuel tank. This clever setup takes advantage of lightweight carbon composite structures, cutting overall mass and boosting efficiency. During flight, once the first stage's fairing opens up in space, the second stage is released, ignites its Archimedes engine, and carries the payload to orbit, a streamlined approach to staging. As Peter Beck might put it, it's basically a one-time deal, like a cosmic getaway car. Of course, with this kind of setup, Neutron's second stage is unlikely to be fully reusable. At best, Rocket Lab might be able to recover certain parts of the fairing. Still, opting for an expendable upper stage allows the company to sidestep the ongoing costs and complexity that come with refurbishing reusable upper stages. So that's how Neutron will carry out its mission. But here's a quick question. How is this rocket actually going to land? Well, on July 11th, the company proudly announced a partnership with Bollinger Shipyards to complete the build-out of a massive 400-foot landing platform. Oh wow, Rocket Lab is going big, really big. The drone ship will be almost as long as a Starship rocket. This is where Neutron will touch down after returning from orbit, at sea, on its very own customized drone ship. In other words, Rocket Lab is borrowing a page straight out of SpaceX's playbook, with Falcon 9-style ocean landings. That's why the Neutron's original design already included fixed landing legs. And this is actually a pretty advanced engineering choice. Fixed legs don't need to fold out or retract, which eliminates a major point of failure. If your landing gear doesn't deploy or lock properly, your rocket isn't landing. End of story. But the real beauty of fixed legs comes from reusability, which is the whole point. Since they never have to be stowed before launch, they need far less inspection or refurbishment between flights. Fewer moving parts means faster turnaround, lower costs, and more launches. Now, there is one interesting detail here. Even though Rocket Lab calls them fixed, the animations show the legs moving slightly, sliding down vertically to absorb the impact. It's minimal motion, more like a built-in shock absorber than a traditional deployable leg. So while they're not 100% static, they're still far simpler and sturdier than folding legs. In other words, the best leg is no leg, as Elon Musk often said. The excitement doesn't stop there, because Neutron will be powered by a brand new engine called Archimedes. This one's built entirely in-house by Rocket Lab. At first, the plan sounded pretty modest. 7 engines, a gas generator cycle, about 1 meganewton of thrust each, roughly 102 tons of force. Solid numbers, but nothing too fancy. But along the way, things changed. Big time. the latest specs show much higher efficiency, and instead of 7 engines, Neutron's first stage will now fly with 9 Archimedes engines. Why the change? Well, the gas generator design was running into trouble. The turbines were getting way too hot, and the trade-offs weren't worth it. So Rocket Lab took the harder route and switched to a closed-cycle design, the kind you'd normally see on bigger, more advanced rockets. The advantage for Rocket Lab is that Neutron's lightweight carbon composite body means Archimedes doesn't have to be pushed to the extreme like Falcon 9's engines. They can keep the design a little simpler, which speeds up testing and development. And speaking of testing, back in January, Rocket Lab lit up an Archimedes prototype on the stand for the very first time. Just a short ignition, but a big step forward. Full-duration hot fire tests are coming soon, and those will really show whether the engine can live up to the hype. Another major development, beyond Archimedes, has to do with the materials used in Neutron. It's set to become the first large launch vehicle in the world, built entirely out of carbon composites. Rocket Lab already proved the concept with its smaller Electron rocket, which has been reliably putting commercial and government satellites into orbit since 2018. Neutron, however, takes things a step further with a brand new carbon composite that's lightweight, incredibly strong, and able to handle the brutal forces and temperatures of launch and re-entry again and again. That durability is what makes the first stage truly reusable. To speed up production, Rocket Lab is using an automated fiber placement system that can churn out meters of carbon rocket shell in just minutes. All of this highlights Rocket Lab's bold ambition to make Neutron a reliable workhorse in the medium lift market, especially now that it's been selected for the U.S. Space Force's National Security Space Launch Program. With its debut flight expected by late 2025 from Wallops Island, Virginia, Neutron's lightweight structure and powerful performance could give it a real edge in one of the most competitive corners of the launch industry. Overall, Rocket Lab is clearly on the rise, and they might even threaten SpaceX's dominance in the satellite launch market in the future. Meanwhile, Blue Origin is still mostly known for its space tourism flights on the oddly shaped New Shepard. That's why this bold move, securing Launch Complex 3, could actually become a turning point, maybe even the first real step toward outpacing Blue Origin. Lately, it seems like some SpaceX fans have quietly drifted away, or disheartened by the string of setbacks surrounding Starship and the company's ground infrastructure. But let's be fair, this is still just the beginning of a long and ambitious journey. Elon Musk's ultimate goal has always been Mars, and what we're seeing now is simply the first chapter of that mission. However, there is one company that's quietly edging closer to the level SpaceX has achieved, and that's Rocket Lab. Their small but reliable Electron rocket has completed 68 orbital launches with only 4 failures, an impressive 94% success rate. Who knows? Maybe one day they could even challenge some of SpaceX's records. It's a long shot, sure, but you can't ignore the progress they've made, especially when you compare them to Blue Origin. Bezos' company has pulled off 13 successful crew suborbital flights with crew on board, taking 70 passengers on a few minutes trip to the edge of space. And yes, they've made around $8 million per flight from selling 6 seats, but that's still far behind the kind of revenue that comes from launching satellites into orbit, like what SpaceX and Rocket Lab are doing. All right, back to the main point. So, what exactly has Rocket Lab done recently that's making even SpaceX keep a close eye on them? Well, surprisingly, it's the fact that they just launched 2 Electron rockets back-to-back within 48 hours. Now, sure, that might not sound too crazy when compared to SpaceX. After all, Falcon 9 flew 3 missions in under 37 hours just this past April. But here's the thing. Rocket Lab is a much smaller player. They normally launch 1 mission a month, sometimes even slower. So, pulling off 2 launches in just 2 days? That's a major leap forward. And it's exactly the kind of progress that makes competitors pay attention. The first of the 2 launches took place on June 26th, successfully delivering 4 satellites for Hawkeye 360 into orbit. Then, just 2 days after that, Rocket Lab's Electron lifted off from Launch Complex 1 in New Zealand at 3 a.m. local time on June 28th. Less than an hour after launch, the rocket's upper stage successfully deployed its payload into a 650-kilometer sun-synchronous orbit. Rocket Lab didn't share much about the mission, choosing not to respond to media questions regarding the payload or the customer. Even so, many in the spaceflight community believe the launch was commissioned by EchoStar, a US-based telecom company that also worked with SpaceX earlier this year to launch their Lyra satellites. It marked the shortest turnaround yet between two missions launched from Rocket Lab's New Zealand site. Following the launch, Rocket Lab's CEO Peter Beck said in a statement, "The future of space is built on proven performance, and Electron continues to deliver beyond expectations amid a packed launch schedule this year." That statement felt almost like a message to Rocket Lab's competitors, a quiet warning that the real push is coming later this year when the race gets even more intense. In a way, it also hints at something deeper. Some of SpaceX's customers could soon be slipping into Rocket Lab's hands. And that's actually a pretty big deal, because launching a satellite on Rocket Lab's Electron costs about $7.5 million per flight, while SpaceX's Falcon 9 comes in at around $67 million. That means Falcon 9 appears nearly 9 times more expensive. Now, naturally, most customers tend to go for cheaper options if they still offer good quality. But let's not get it twisted. Electron is only designed for small payloads like CubeSats, with a maximum capacity of about 300 kilograms. That puts the price per kilogram at roughly $25,000. Meanwhile, Falcon 9 can carry up to 22,800 kilograms to low Earth orbit, which brings its cost per kilogram down to just $2,700. That's why, despite the high total price, SpaceX continues to win big government and military contracts, $5.9 billion worth, to be exact. It's not just about price, it's about capability, reliability, and trust for bigger, more important missions. Behind its modest payload capacity, Rocket Lab's Electron is a 2-stage rocket standing just 18 meters tall and 1.2 meters in diameter. Its first stage is powered by 9 Rutherford engines, producing 190 kilonewtons of thrust at liftoff and peaking at 224 kilonewtons, roughly 22.8 metric tons of thrust. Still, it's pretty impressive that a rocket this small, with relatively limited thrust, can reach orbit. That's something not every large, oddly shaped rocket looking at you, Blue Origin, can claim. The Rutherford engine, used on both stages of Electron, runs on RP-1 and liquid oxygen, a common propellant combination in aerospace. All in all, it's a well-deserved win for Rocket Lab. Their hard work is clearly paying off, as they've managed to pull ahead of Blue Origin in the satellite launch market. So far, Jeff Bezos' company has yet to successfully launch a single payload for a customer, despite having signed launch contracts with several major clients. On November 14, 2024, they reached an agreement with AST SpaceMobile to launch Block 2 Bluebird satellites to low Earth orbit between 2025 and 2026. Blue Origin is also set to deploy satellites for Amazon's Project Kuiper, a low-orbit internet network aiming to compete with SpaceX's Starlink. But with Starlink already serving over 5 million customers, Kuiper is facing an uphill battle, and some might say it's a lost cause. In addition, Blue Origin has been tasked by NASA to launch the Blue and Gold satellites for the ESCAPADE mission, which will study solar-wind interactions at Mars. That mission, originally planned for 2024, has been delayed and is now expected to launch in the third quarter this year. You probably already know the reason why, right? They've signed multiple contracts, but nothing's been delivered, mainly because their New Glenn rocket has run into quite a few setbacks, especially from late last year into early this year. Between August and September 2024, they experienced hardware issues, including bent components due to employee error. Then in September, they were fined $3,250 by Florida's Department of Environmental Protection for using a water deluge system during a static fire test without the proper permit. In early January, they had to scrub the NG-1 mission 4 times before finally managing to launch on January 16th. Fortunately, things eventually turned in their favor. That first launch, NG-1, successfully delivered the Blue Ring Pathfinder satellite into orbit. However, the booster was lost during its attempted landing on the Jacqueline ship in the Atlantic Ocean. Telemetry showed that 3 out of the 7 BE-4 engines failed to reignite properly, causing the booster to be lost at Mach 5.5 and an altitude of 25.7 kilometers. Since then, they've been struggling to fix and upgrade the vehicle. Most recently, several internal sources have revealed that the next New Glenn launch is now scheduled for no later than August 15th. Many believe that the upcoming launch might be the first step toward flying NASA's Escapade mission on New Glenn's second flight. The mission involves sending a pair of small spacecraft to Mars to study the planet's magnetosphere. However, since Blue Origin missed the previous Mars transfer window last year, they'll have to wait until the next one opens at the end of next year. That means, while a nominal launch might still happen this fall, the spacecraft wouldn't be able to reach Mars until late 2027. None of this information has been made public. Instead, Blue Origin's official page on X is currently flooded with updates about NS-33, yet another space tourism flight, following the all-female crew drama that made headlines not long ago. Their suborbital New Shepard rocket lifted off on Saturday at 9:39 a.m., carrying 6 ultra-wealthy passengers more than ready to spend a fortune, essentially pumping cash straight into Jeff Bezos' pockets. Coincidentally, that very same day also happened to be Jeff Bezos' wedding to his fiancée, Lauren Sanchez. The lavish ceremony took place in Italy, with Bezos reportedly shelling out nearly $30 million to host the event and invite a star-studded guest list. According to some sources, he even invited President Donald Trump, possibly hoping to forge a connection now that Trump's relationship with Elon Musk seems to have soured. In the end, Trump didn't show. Whether due to a scheduling conflict or a quiet decline, no one knows for sure. As for Musk, Bezos' longtime rival, he was nowhere to be seen at the wedding either. But here's a question. Do you think Jeff Bezos even invited him? Back to NS-33, as usual, the flight lasted about 10 minutes, reaching an altitude of approximately 105.2 kilometers above Earth. Among the passengers was Carl Quainer, chairman of Building and Land Technology. According to the Space Explorers Association's Registry of Space Travelers, he officially became the 750th person in history to fly into space. Overall, at this point, Blue Origin is putting all its hopes on New Glenn as its direct answer to SpaceX's Starship. But they'd be wise to keep an eye on Rocket Lab too. The company's Electron rocket reflects a team aiming high and moving fast as the year progresses. From its payload capabilities to its high success rate and reusable features, every part of Electron has been built with a mix of ambition and practicality. Looking ahead, Rocket Lab is focusing on optimizing its upcoming Neutron rocket for reusability and ambitious missions, including launching 1,500-kilogram payloads to Mars or Venus. It's shaping up to be a valuable workhorse for future Artemis-related lunar missions, and potentially much more. So, do you think Rocket Lab and its Neutron rocket have what it takes to surpass Blue Origin and New Glenn? Let us know by answering yes or no in the comments below. And don't forget to like the video and subscribe to Alpha Tech for more updates on space companies and the ever-evolving world of cosmic exploration.